Part 2 of today still deals with graphing equations and writing equations of lines. In this portion, we're just going to kind of experiment with a couple of these forms, which we have slope-intercept form, which we talked about already, y equals mx plus b, and then we also have point-slope form, which are both basically just, a derivative of the other. So y minus y1 equals m parentheses x minus x1. And you'll always, when you're rewriting your equation, right, have a value for m and b, for your y1, for your slope, and then your x1. So these are just things to keep in mind as we're playing with some of these. For this first one, we're wanting to write an equation of a vertical line passing through AD, right? So we're passing through a point. Vertical line, right, box, meaning vertical line, undefined slope, x equals. What is x equal to in this ordered pair? That's right. So x equals a, right? And if there was a value in there, we would just name it as x equals whatever that number was. Okay. What type of equation of a line passing, write the equation of a line passing through -2, -5, and 6, -2. What I'm noticing in each of these points is that we have the same value in each of these spots. So we know that in both of these ordered pairs, y equals -5. So we can cut straight to the point and notice that that's going to be that horizontal line that runs through the value of -5. And that line, like I said, would be a horizontal one. Write the equation of a line with a slope of 4 and passing through 0, -3. So already I know my slope is 4, and then passing through 0, -3. The only way that we can identify this as the y-intercept is because our x value is 0. So this is our y-intercept, 4 is our slope. So it's pretty straightforward. When we're creating our slope-intercept form, our b value is 4, our m value is 4, our b value is -3. So there, we're done. We want to write the equation for number 7 of a line in point-slope form that is perpendicular to the line y equals 5x minus 8 and passes through 4, -7. So perpendicular to the line this. So how do I find a perpendicular slope to the original line? Well, my original slope is 5. My new slope is that perpendicular relationship. So the new slope is going to be that opposite reciprocal. The point that this new line is passing through is 4, -7. So this is all my new information. This stuff is what I'll be plugging into my point slope form. So y minus y1 parentheses or equals my slope parentheses x minus x1. This minus a negative flips to a positive. And again, the reason I was able to plug this in as is, this is my x1, this is my y1. That is identified as my slope. And then at this point, we're just asked to keep it in point slope form. So we can keep that as is. Okay. Here are some additional practice problems. We're writing the equation of a line with a slope of 3 passing through 4, -5. And this is just a couple of varieties that we have. I notice that my slope is 3, and then the point that I'm given is 4, -5. What I think is going to be the easiest is to apply point slope form, because I have a slope and I have a point. So why not use my point slope form, plug it in to at least set up what that question is, and then I can do some translations to figure out the slope intercept form to get that y by itself. So starting off just with my formula, y minus y1 equals m parenthesis x minus x1. My m I already know is 3. My x1 is 4. My y1 is negative 5. So y minus a negative 5 equals the slope, parenthesis x, minus the x1 is 4. Minus a negative flips to a positive, and this is my point slope form. I'm done. But I could take this a step further, right, and solve and simplify to get y by itself. So all I'm doing is I'm going to move this over here and then do my solving and simplifying. Distribute the 3 to both those terms. Subtract 5, and I get y is equal to 3x minus 17. So these are two forms that are pretty interchangeable. Do they look the same? No, but they're just two different forms to write the same exact function. Okay, let's try one more, dealing with 2 points, and we're trying to write an equation of a line passing through these 2 points. So my 2 points, we have 4, 9, and then 6, 10. So I have a point, but notice in both of these, I need a slope. So my best suggestion here is to find your slope. So slope formula, y2 minus y1 over x2 minus x1. Subtracting the y's, 10 minus 9, and then subtracting the x's, 6 minus 4. This simplifies to 1 over 2. So my point, or my slope, is 1/2. And then my point, I have the choice. I can use this point, or I can use this point. I'm going to use the point that's boxed, just simply because I boxed it first. So, because I have a slope, because I have a point, I always think using that point slope form is going to be the most beneficial, the most straightforward way. So, I'll start with just my formula and then plug in what I know. So, I know y minus, and then my y1 is 9. My slope is 1/2. X minus x1, which is 4. Close those parentheses. In point slope form, I am done. There's no additional simplifying to do. But I can transform it, this equation, right into slope intercept form. So I'm just going to copy this down, so you know, looking back on it, where you got that from. Distribute that 1/2 to both of those terms. And then that final step, isolate y. Y is equal to 1/2 x plus 7. Slope intercept form, point slope form. And again, both of these are interchangeable. They really represent the same exact problem. One is in slope intercept, one is in point slope form. And again, test questions might ask you to put these equations in different forms. So just be aware of that.